So now we're going to start getting into what we call key features of linear functions, and it's kind of just describing the properties or the way that these functions behave, I guess. So we're going to start off with this idea of domain and range. So domain, as the definition up here is the set of all possible inputs, which is like our x, our inputs are our x for the function. So it says here, without any constraints, the domain of all linear functions is all real numbers. If they go on forever, there's no restrictions on that x. If the graph has any endpoints, though, the domain becomes restricted, which we'll then express the domain with inequality or set builder notation. So there's a different kind of notations or formats in which you can write this stuff. So here are just some examples. So like this one up here in the top left, its domain is all real numbers because in the x, remember, we're just talking about x. So this is our x-axis. I just kind of put an x on my x-axis in green here. It's going to go on forever. It's got those arrows out here, right? It's going on forever. So it's all real numbers. It's never going to stop. There's no restrictions in terms of the domain. It's going to go on forever. So how you write, you can either just kind of say all real numbers, but this is the symbol for it. X could be all real numbers. And I was bringing up this set builder notation. Sometimes you might see it like this. It'll be like, it could be X such that X is all real numbers. So it might look like this, but it's basically the same thing. It's just like a fancy way of saying X is all real numbers, okay? And so like on the second one, on the top right here, we have the domain where X is greater than or equal to -3. This one isn't all real numbers because look, it's got an endpoint right here. It doesn't have an arrow. It's not going this way forever. It's not doing that. It's stopped right here. It's never going to go. Remember, looking at X, looking at the X-axis, it's never going to get to -4. It's never going to get to -5. It's never going to go to -6. It's never going to go out this way. It's never going to go out here. It's only going to be, this graph only goes from -3 onward. So the domain, as it's read down here, is that X is greater than or equal to -3. It's never going to be less than -3. It's because the domain is when X is greater than or equal to -3. And again, I'll just say this again. It might be written in this set builder notation where we say, okay, the domain is X such that X is greater than or equal to -3. But this means the same thing. Don't let it confuse you if you see it in this kind of set builder notation. It's the same idea. So I'm probably going to stick to the inequality notation for the most part here without all this set builder stuff. Okay, and then even this example down here, like again, this line is not all real numbers. It has an endpoint. It's never going to get to 3 or 4 or 5 or 6. It's never going to go out here. It's only going to have numbers for X that are less than 2. That's why the domain says X is less than or equal to 2. Because it's only going to be 2 and numbers less than that. Because it's going to the left. It's for X. So that's why the domain is X is less than or equal to 2. A kind of last example here is where we have 2 endpoints, right? Whoops. We have an endpoint right here and an endpoint right here. It's never going to go to 2 or 3 or 4. It stops. It's never going to go out here. It's never even going to go out here. It stops. The domain, it's only going from -5 to 1. It's only going to be within the domain. The X values are only going to be those values. That's why the domain is as it's listed. Remember, this says X is, if you read it, this way, X is greater than or equal to -5 and less than or equal to 1. That's the domain for that one. So let me show you some fresh examples because those ones were technically done for us. It says, write the domain for the following graph. So we're only looking at x. We're talking about the x-axis. Remember, this is our x-axis. Now it has arrows in both directions. So there's no restriction on this domain. It's going to go on forever this way. It's going to go on forever this way. Any value of x, this graph is going to go to. So the domain for this function is all real numbers. So I'm going to say the domain x can be all real numbers. You draw this kind of fancy looking R, signifies all real numbers. Let me do C. Now C doesn't have arrows on both ends. There's an endpoint to it, right? And I'm going to draw a little dotted line for visual sense. It's never going to go to 0 or -1 or -2. It's never going to go in that direction. When we're looking at the x, remember this is our x-axis. When we're looking at our x, it's got to be greater than or equal to 1. That's the domain where x is greater than or equal to 1. It could be 1, 2, 3, 4, 5, 6, 7 forever, right? It's never going to be less than 1. So that's going to be greater than or equal to 1. E has a couple endpoints, here and here. Now, if I look at the x, again, I'm going to draw this dotted line just for the visual. If I look at this x-axis, the domain of that line is from -2 to 4. It's not going to go to -3, -4, -5, -6. It's not going to go out that way. It's not going to go to 5, 6. It's not going to go any of that way. It's not going to go out here. The domain is just from -2 to 4. So how I'd write this is x needs to be less than or equal to 4, but greater than or equal to -2. That's my domain. Okay? Next is range. Range is the same concept, except y. It's the possible outputs for the function. So when we're asking for range, we're not going to be looking at the x-axis or the x numbers. We're going to be looking at the y-axis or the y numbers. So here are some examples for you. This one, all real numbers. We're looking at y now because it's going to go up forever. We're looking at the y-axis. It's going to go up forever. It's going to go down forever. All real numbers. There's no restrictions. Meanwhile, on the second one here, got this dot. You kind of draw a dotted line here. It's got an endpoint right here. And it's never going to go above 7. It's never going to get, remember, we're looking at the y-axis. It's never going to go to 8 or 9. It's only going to go downward from there. So the range is y is less than or equal to 7. It's got to be less than or equal to 7. That line's going down from 7. Everything below 7. So y is less than or equal to 7. And just, I'm going to draw a set builder notation. It might also be written as y value such that y is less than or equal to 7. That's it. It might be written like that. Don't let it confuse you if you see it that way. It's still the same concept. That's still the same. This one here has an endpoint too. It's never going to go below -5 in our y. So that's why it says y is greater than or equal to -5. It's only at -5 and up. This one has a couple endpoints, here and here. But this is where a lot of students mess up because they start looking at the x, but we're talking about the range. This one's asking for the range. So the highest it's going to go is 4, and the lowest it's going to go is 1. That's why the range is from 1 to 4. It's not going to go here, 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 or here. The range is from 1 to 4, where y is greater than or equal to 1 or less than or equal to 4. So let's do some fresh examples. So write the range. So A, all real numbers. It's going to go up forever. It's going to go down forever. So Y, all real numbers. Let me show you C. Remember, we're looking at the y-axis. So we're looking at the y values. So y. So I'll draw a little dotted line for reference here. But what you should see, dang it, sorry, that dot's bothering me. Ugh, erase. Heck. Okay. What you should see is that the y value, it's never going to go below 3. It's 3 and up. So the range is that y needs to be greater than or equal to 3. That's the range. And then E has a couple endpoints here and here. If we look at the range, so again, we're range up and down, our y. Looks like the highest this goes is 0, right? Because that's on 0. And the lowest it goes is -6. So y needs to be less than or equal to 0 and greater than or equal to -6. I know this can be kind of tough. We're going to be doing domain and range a lot this year. So this is kind of introductory. Let me do a couple where it's asking for both domain and range. So number 3 says, write the domain and range for the following graphs. I'm going to let you do A, just, it's got arrows in both directions. So hopefully you remember what that means in terms of both the domain and the range. But B doesn't. It's got a little endpoint here. So the domain, let me do that first. We look at the X. Domain is always X. And if we look at this line in terms of its X, or X-axis, it's going to be -3 and greater because it's going this way, right? So it's never going to get to -4 or -5. So the domain would be X needs to be greater than or equal to -3. That's the domain. -3 and onwards. Now let's think about the range. The range is our y. So the range, it's never going to go above 5. It's everything less than or equal to 5. So the range is going to be y is less than or equal to 5. Let me show you C. It's got 2 endpoints. Let me do the domain first, looking at our X. So it looks like it goes from -2 to 6. It's restricted in that way, right? So the domain would be X needs to be less than or equal to 6, but greater than or equal to -2. That's the domain. -2 to 6. Now the range is referring to the y. Let me erase this blue stuff real quick here. The range is referring to the y-axis. So the highest it goes is 3. The lowest it goes is -1. So the range is y would need to be less than or equal to 3, but greater than or equal to -1. Okay, so do your best with domain and range on the rest of the problems.